Hello everyone, this is our Digital System Laboratory final project, and our project name is Music Recorder. Let's move on to the table of contents. This presentation will cover the following topics: inspiration, feature and code, demo, challenge during development, future prospect, and feedback. First is our inspiration. Our inspiration stems from our shared musical background. Both of us have over 3 years of experience in learning music. Starting from our shared background in piano, we noticed that most pianos do not have the ability to record previous performance. Therefore, we decided to build upon the act of playing by adding a record function, allowing the music to be remembered and revisited. Next, let's talk about features and code. Our music recorder includes a display mode using a 7-segment display, recording and playing function triggered by keys, and octave and note control via switches. Now let's dive into the code in detail. The code is written in Verilog and is divided into several key modules. First, the basic I/O definition set up the input and output registers. We define inputs like clock, switches, and keys, and output like the 7-segment display and audio signals. These make it easy to select a pitch using just an index. Third, octave-based note mapping. From switch 7 to switch 1 is like a virtual keyboard. Only one switch should be turned on at a time to present a note. Now, switch N and switch 9 are used to shift the octave. If switch 8 is on, we pick a higher octave. If switch 9 is on, we select the middle octave. If neither is on, we go to the lower octave. So, by using the combination of these switches, we can play 21 different notes. Fourth, playback and recording program. Let's move on to how the system handles recording and playback. When you press key 1, it starts to recording. Press it again, stops recording. During recording, whenever the switch changes, we store the select note and how long it was held. We can store up to 32 notes in total. When you press key 2, the system plays back all recorded notes in correct order and with the right duration. It uses record timer and play timer to track how long each note is held or played. This all managed with simple control logic and clear system states, idle, recording, and playing. Fifth, square wave generation for audio output. To actually make sound, we need to create a square wave using PWM. We calculate a divider using a formula, PWM divider equal to clock frequency, and then divide note frequency. A counter flips the output signal when it reaches the divider. This produces a square wave that we send to the speaker. If note is selected, current frequency equal to 0, the system stays silent. It's very efficient and clean way to produce audible tones using hardware. 6. 7-segment display. To keep the user informed, we display the system current state on 6 7-segment displays. It will show play, record, or done. This is done using simple combinational logic that upgrade the display based on the current state. It makes the system more user-friendly and easier to debug. 7th, debouncing logic. Finally, let's talk about button debouncing logic. Mechanical button bounce, which can cause multiple triggers. To prevent this, we use a counter to sample the button state every 20 milliseconds. We detect a value pressed by looking for a fallen edge when the button goes from high to low. This ensures that each button press is counted only once, and the system behaves reliably. We apply this debounce logic separately for both key 1 and key 2. Next is a demo of our final project. Let's move to the challenge we face during development. We encounter unfamiliar concept, synchronization issue between recording and playback, a limited musical range of only 7 notes, and time constraints. To overcome this, we used AI assistant for learning and troubleshooting, standardized time units for precise synchronization, expand to 21 tones scale across multiple octaves, and pulls multiple all-nighters. Next, let's explore future prospects. We plan to add screen output support for better visualization and an external button interface for easier control. Additionally, we aim to enhance the recording experience for smoother playback. Last is the feedback from others. The first person found the music box creative design really engaging. It's great for living performance and story playback, which is perfect for practicing tricky pieces. The interactive switch and key control make it fun to experiment with notes and octave. The second person says that he loves using the music box. It's so cool to record and play back simple tunes with a push or button. The 7-segment display helped him know when he was recording or playing, which was super helpful as a beginner. Thank you everyone for listening to our presentation.